A disk of radius r with uniform positive charge density sigma is placed on the xy plane with its center at the origin. The Coulomb potential along the z-axis is given by Vz is equal to sigma by 2 epsilon naught into 1 plus into under root of r square plus z square minus z. A particle of a positive charge q is placed initially at rest at a point on the z-axis with z is equal to z naught and z naught greater than 0. In addition to the Coulomb force, the particle experiences a vertical force F bar is equal to minus c k naught with c greater than 0. Let beta is equal to 2c epsilon naught by q sigma. Which of the following statements are correct? Options are given. Now we are going to discuss about this. Particle reaches the origin and particle, they are giving that actually whether particle reaches the origin with this beta and z naught or it returns back. Now we will see that. First, take a disk. From this disk, let us consider that a charged particle q is placed at distance z is equal to z naught. Now, on this particle, we can see because of this surface charge density sigma, you can write this as potential is V is equal to sigma by 2 epsilon naught into r square plus z naught square under root minus z naught. This is the given question. Okay, in the question it was given that V is equal to sigma by 2 epsilon naught into under root of r square plus z square minus z, and also given that force acting on this charged particle F is equal to minus c k. You can observe that F bar value. So if you see that on this force is acting this side, now we are going to calculate dF is equal to, you know that, minus du by dz. The same manner we can write the du value also, or u is equal to minus integral f into dz minus integral f is minus c into dz. Let us consider this is varying from 0 to z naught. We can write c into z naught. U is equal to c into z naught. Now again we can observe that at this point the net potential is can be written as initial point. I am writing here at initial position. Initial potential energy is equal to q into v plus one more u. Q into v is q into sigma by 2 epsilon naught under root of r square plus z naught square minus z naught plus c into z naught. Then what is the c value? According to question, beta is equal to 2c epsilon naught by q sigma. 2c epsilon naught by q sigma. You calculate the c value. You can write the q c is equal to beta q sigma by 2 epsilon naught. Substitute the value here. Initial potential energy is q sigma by 2 epsilon naught whole thing into r square plus z naught square under root minus z naught plus c value also. If we substitute that, we can write beta into z naught will get. So finally we can write it as q sigma by 2 epsilon naught r square plus z naught square under root plus beta minus 1 into z naught. This is the initial potential energy of the particle when it is located at z is equal to z naught. It is dropped. Initial kinetic energy of the particle is 0. Whenever this particle is reaching here, let us consider final kinetic energy is kf, and final potential energy, we can see this location is, this point is z naught is equal to 0. Z is equal to 0. If Z is equal to 0, then final potential energy can be written as sigma by 2 epsilon naught into R. Now use the conservation of energy. Conservation of energy. If we use the conservation of energy, we can write initial kinetic energy plus initial potential energy is equal to final kinetic energy plus final potential energy. Initial kinetic energy is 0. For initial potential energy value is q sigma by 2 epsilon naught into r square plus z naught square under root plus beta minus 1 into z naught is equal to final kinetic energy plus final potential energy is sigma r by 2 epsilon naught. Now substitute there, final kinetic energy can be written as q sigma by 2 epsilon naught. I forgot this is q, here q also will be there. Actually u final value is equal to q into v final. Okay, q sigma by 2 epsilon naught taken common, we can write the r square plus z naught square under root plus beta minus 1 into z naught minus r. This is the final kinetic energy of the particle. You just observe that final kinetic energy of the particle. Now according to question, if you observe this, particle is reaches the origin or particle is coming back. Two relations they have given. So when can the particle reach the origin? When can it return back? If final kinetic energy is greater than 0, or we can say that final kinetic energy is positive, we can say that particle reaches the origin. Particle reaches origin. Next, if final kinetic energy is negative, then particle return back. Return back without reaching origin. Origin is nothing but z is equal to 0 location. Now let us consider one of the options is that beta is greater than 1, z is greater than 0 is given. Let us consider a situation like this. If beta is equal to 1 and z naught is equal to 0. This condition, if you write this, k final can be written as q sigma by 2 epsilon naught r square plus z is 0 plus beta minus 1, this value is 0, minus r will get. So finally kinetic energy is 0. So in this situation it just reaches the origin. But according to question, if beta greater than 1, z naught greater than 0, obviously it will reach the origin only now. So first option we can see that if beta value greater than 1 and z naught is greater than 0, in this case we can observe that particle always reach to the origin. Reach to origin. Okay. Now this is the situation. Option D is correct. Now observe for the remaining options. For beta is equal to 1 by 4, z naught is equal to 25 by 7. A option. If beta value is 1 by 4, z naught is equal to 25 by 7r. Final kinetic energy value, you know that q sigma by 2 epsilon naught r square plus z naught square is 25 by 7 whole square r square under root plus beta 1 by 4 minus 1 into r minus r. This is the value. Substitute there. Q sigma by 2 epsilon naught, here r square and 45 and 625, we can write 674. You can write this as r into root 74 divided by 674 divided by the 49 minus 3 by 4 r minus r into z naught also there. Here the z naught value is 25 by 7 into r minus r. You substitute the value of this. You can write minus 3 by 4 into 25 by 7 r square minus r sorry, this is r only, r. You substitute properly. Q sigma by 2 epsilon naught into root 674 divided by the 49 is there. So if you calculate the value of root 74 minus this, okay, and this value, you will see now like this, 25.9 something, 96 or something you will get, divided by the whole thing is like this, 7r minus 75 28. You can see that 103 minus 103 r divided by the 28. If you see that this value is slightly greater than this value is greater than this value slightly, okay, so we can get the kinetic energy is positive, greater than 0. So from this we can say that particle reaches the origin. You check for the option D. Option A is correct only. Option D, 1 by 4 and 3 by 7. Beta value is 1 by 4. Z0 is equal to 3 by 7r is there. 3 by 7r. In this case, again, if you substitute the values, k sigma value, k final value is equal to q sigma divided by the 2 epsilon naught under root of r square plus 9r square by 49 under root minus, we can write it as minus 3 by 4 into z minus 1 is what, so beta minus 1 is what, 3r by 7 minus r. So we can observe this q sigma by 2 epsilon naught into 49, this root to 58r divided by the 7 minus, this can be written as 9 and 28, this is 38r divided by the 28. Here if you see that this term is less than this term, slightly less than, so you can say that this value is less than 0 is coming. Particle return back before reaching origin. So option B is wrong. Apply now 1 by 4 and r by root 3. C option. Beta is equal to 1 by 4 and Z0 is equal to r by root 3. Again you calculate kf is equal to q sigma by 2 epsilon naught into r square plus r square by 3 under root minus 3 by 4 into z value is r by root 3 minus r. You substitute there q sigma by 2 epsilon naught into 2r divided by the root 3 minus 9r by 4 root 3. Here also if you observe this term is less than this term. So you can write kf is equal to, kf is less than 0, negative value will get. So it indicates that particle returns back before reaching to origin. So from this we can see that option C they have given as it is returned back to the z is equal to z0. So there is a possibility of giving z is equal to z0. So from this we can see the correct options from question number 12 is A, C, D or